Clustering means the data is organized on patterns, and then they start working on filtering. And when you have regression, and they work like predictions. Predict, please, the price of my house, how much they will be in 6 months from now. Predict the stock markets. Predict a video, how well we will be receiving. A lot of things like that. And one example, as we saw, of machine learning is the machine needs to learn by itself with your help. If I show my machine learning a photo of a dog and a table, it will know that two different things exist, dog and table. That's how they know. If I show a photo of a dog that I showed before, they will recognize is a dog. If I show a photo of different kind of dog, depending on the algorithm using, if it's looking for a pattern, it will determine that this is a dog because the shape looks like a dog. But as soon as I start feeding with more knowledge, thousands of photos of dogs, they start recognizing the dogs come in different shapes, sizes, colors, and the same for tables. More information you give, better predictions you can have. And this is a lot of things you can do with machine learning. Due to the time restriction, I just try to go a little bit faster, but that was my first goal. My first goal was to how can I let everybody here understand what machine learning is. That way, next time, you have a point of discussion. And I can tell you that machine learning is something that everybody needs to be working on at the moment. And the things we're going to be seeing now, how to use machine learning with Oracle, are very important. For developers use it a lot of machine learning with Python. That means if you're a developer, I recommend you to take a look on machine learning, take a look on Python, and Python you also can use it against Oracle. Now let's talk a little bit of autonomous data warehouse. How many people here saw, played, or knows about autonomous data warehouse? One person, 2, 3, 4, 5. Okay. All right. Looks like everybody's new to autonomous data warehouse. That's good. In the past, when we work with deploying an environment, let's see a data warehouse environment, they take weeks, if not months, to deploy. First, we need to get the hardware, all the infrastructure also, let's see, I have a project now. I need to pump the resources. I can go on the fly, improve the number of memory and CPU of my my environments using with zero downtime. I don't need to shoot down to go up. I can just tell on the fly. Everybody goes up and start using, and I can go down on the fly too. Other technologies in the markets allow you, when using virtualized environments, to go up, but with zero downtime, but they don't allow you to go down with zero downtime. Oracle allows you to do that. It's very easy to provision a database, grow and shrink, as I mentioned. Patching in upgrade is done for you automatically. You can forget about the security patchings. You can forget about the upgrade, and everything is done for you in an organized way. Oracle is the only provider in the cloud they can sign off on SLAs. Amazon, Google, Azure cannot do that. And as I mentioned, it's zero tuning, it's simple web-based monitoring console, and the built-in resource plans management make everything very easy. This is one example of dashboard that you can take a look how the things are going on your servers in your instance. You can see the database activity. You can take a look on basically everything as you saw before, but Oracle in the background is taking care of everything for you. A lot of people tell me, Francisco, but this is the end of the DBAs. No, that's not the end of the DBAs. DBAs do not stand anymore for a long time as database administrators. They are database architects. My main problem when I was speaking to DBAs in the past few years were that you are losing too much time doing what we of that is easy. It's already integrated with the data visualization, report, and data analysis for BI. It's web-based. It's very simple to use, nothing to install. You can start using straight away. It's an autonomous setup and configuration. Basically, all I need to do is load my data and I'm ready to go. They have tons of load templates ready to go that you can start playing and using. And it's very, very simple to use. Okay, what's Oracle ML? Basically, it's building, as I said, a web base. Is bundled with the autonomous data warehouse. It came from an improvement of the Apache Zeppelin, provide best web-based SQL access to your autonomous data warehouse. It's simple and powerful set of data visualizations. Is a sharing collaboration framework, and our workspaces, projects, notebooks are saving inside your database. You don't need to do backup of your projects. They are always saved with all the backups of your database. How that works, basically, I have the web-based machine learning notebooks. They will connect to your database on basically compiling using SQL codes, SQL machine learning algorithms, your SQL function, you check for analytics views, pattern matching, and when you do that, you also can use what we call HTML tags to use a lot of different kind of markdowns. HTML tags, dynamic forms, URL tags, image tags. It's like when you work with creating an HTML page and you manage your text, image, and everything together, you can basically do the same with this tool. And when connecting to the database, as I mentioned, you can connect using a low, medium, or high pipeline to connect to your database environments. The smart way to use the machine learning with Oracle is write SQL using 18C and database analytics, document and annotate everything. More documentation you embed with your machine learning, better is for you and everybody else to understand and use. Build interactive visualizations using markdown tags, collaborate and share. It's very simple to use it with this. Let's get started very fast, take an overview of this problem with Oracle. When I connect, this will be kind of the page you're going to see. I will work with what we call workspaces. A workspaces is a folder where I can have one or more projects, and a project can have one or more notebooks. Notebooks will be kind of the programs I'm going to do for different things I'm doing with machine learning. And when I do that, I can run as a query
So let's get into the topic, right? So microservices architecture. So this is a good definition that I found. It's an approach for developing application as a single suite of small set of collaborating services. Now, what does it mean? In your typical application, you had various functionalities. Those functionalities obviously needs to interact with each other, right? So many times for an ease of interaction, we try to package them together. That means that if you, in layman term, if you have two classes that want to interact with each other, it's much better to put them in the same package rather than you put them in two jars, right? What is easier? I mean, what would you do normally, right? You would rather put in the separate classes and you still that's the packaging, right? So in every layman term, that microservice is more about do you want them to be a separate independent deployment unit? I mean, that's a more question. So as we see, there is when you talk about microservices and these are interacting with each other, there is an application boundary that surround them. Now that boundary is very important because that boundary is what gives you the all the powerfulness that what microservices bring. If you want to talk about fault isolation, you want to deploy it independently, you don't want to have any dependency with each other. If you don't have that application boundary, it's very difficult. So and some of the characteristics I'll cover in the further slide, but you need to keep in mind that if you don't have many services, that's not really a microservice, or at least it will not give you the benefits of microservices, right? So I'm not a judge of making whether it is a microservice or not, but it wouldn't give you the benefits what you're looking for. Now, one of the ways to know whether people are using and how they are using is talking to people, and I get the opportunity of talking to people in many times in interviews, right? So we have the hiring drive. You talk to people around what is the technical architecture they use, and people speak about we have microservice architecture implemented, and I typically ask like how many services. So I hear the answer like we have like 9 services that is communicating, and I ask like how many members are in the team. Then say we have like 8-member team that's one Scrum team that's running. Now so then the next question is that does that give you an independence to move forward very fast? I'm not sure it would really give you, because if you have like 9 services to maintain and you have 8 people, I don't that means the services are very small. Maybe it's a nano service, I don't know. So those are the criteria that you need to decide whether this is really useful for you for your project, particular project. So this is a slide where you talk about the characteristics. That means how do you determine whether what is the microservice, right? So it's organized around business capabilities, which means that it can do one thing and it can do that thing very well. If it's an Hmm. Yeah, so I'll answer your question. Maybe I'll just finish off. So, also considering the time in kind, I'll just keep the questions. Though, to the first answer to your question is that how do you differentiate if it's a microservice or a modular monolith? That's what you're taking. So, microservices should be independent with each other. That kind of rules out having the same database for both microservices, right? Now, we need to make architectural constraints in such a way that it is okay to have a business application such a way, which means that that's where all the monitoring comes in. If you remember in the earlier talk about microservices, there was a lot of monitoring, making sure that both the services communicate fairly okay. And so it gives a lot of overhead in terms of how do you orchestrate the whole thing. It gives you speed while running, but orchestrating is an extra activity that you need to do when you have multiple microservices. I have a slide in which I'll speak a little bit about.
Example of bank, like when you do the money transfer, like this is a good example of microservices or monolithic application, because you are having credit and debit, any transaction fail, and if only one component is developed, it does not write the whole code in that component. It has to go to the other.
Correct.
To talk with that component.
Yeah, you could do it either ways actually. So you could write a microservices, anything you can implement with both the ways. Ideally, I think so typically how to evaluate, right? So I have some slide, and after that I'll try to answer your question. How do you determine? So let's come to this case study what we had. So we are working on an application which is called as Design Portal. It has it's an e-commerce platform which is connected to various ERP systems within the company that I work, Schneider Electric. So we create these tools, design and configuration tools that will, you can just visually create data centers by dragging and dropping racks and seeing what's cooling needed and everything. So we had a tool what's called as Infrastructure Designer. That was an existing tool. And we had a requirement of creating a new tool for us to support a different project. Now the question was, should we, the tool itself, that Infrastructure Designer itself was a separate source code, and that was again a separate application, so there was really no doubt of being a microservices. But the choice was, how do we take this new product in, right? So you do this in both the product together, or rather you will keep it as a separate application and separate service. Now, I'm not calling microservices. I mean, you could want if you could call it the microservices or monolith, but the question was, should you keep both together, or rather you keep separate? Now, we did end up keeping it separate, and so the reason was there were various stakeholders. The stakeholders involved with this particular product was completely different from the other product. That was the primary reason. The teams which are working on this product was completely different from this other product. And we wanted to make this, because it's a new product, we need to make frequent changes, because we know that the rules of that product might change faster than the other product, right? So we decided to keep it as a separate project and deploy as a separate WAR. We deploy our applications as a WAR file, so it's a separate WAR. It's a separate source code, separate team. So I think that qualifies to be a microservices. Whatever be the architecture you use inside. So this application was a separate application. And within the next 3 years, we had 12 more these kind of smaller things coming up. So the choice we took to separate out and create a platform versus one product, it's paid off in the next 3 years, because we had more and more new products coming in that was needed a fast development. Now, because we knew one product was created, it was kind of span out and created this one, the next project was much easier because it was communicating with the standard interfaces with the platform. So because I think it's a modular approach, and you could qualify these are all as an independent microservices. They are not like small project. They are a big project in itself their own, because they have their own logic. They all the application with at least 3 to 4 pages. It has its own UI. All the rules are different. So they are not really a small application. So they like typically a sprint team with for 2 to 3 months worked on that to create that initially, and they have their own life cycle of changes, right? Some of them are very big hardware product that won't change the rules. Some of the, for example, the DCM configurator is a software product. That means that the change is much faster. So all of this has its own rules. And the separation really paid off in terms of how do you respond to the need. because once you need to make change to one of them, you don't need to touch upon the other configurator, right? So this example where we need to move applications because there was a need from a business of separation, right? Now, next example I had is again is a need, which is more frequent need. We had this one of the configurator that was available for registered partners of Schneider Electric. So that means you need to be a certain level of partners. You should be somebody who is selling our product to use the tool. Now, what we have decided from our business decision is that now this tool should be used by everyone. That means even if you could buy it from Schneider, you don't need to. You are not an electrical engineer as well. You need to use this tool. Apart from the tool, it consumed various services. So one of the services was a pricing service that it gives a price. Now the pricing service was actually part of a larger monolith, you could call, or I like to call it as a modular monolith, however it is. So the choice here was, do we allow to keep that pricing service to be a part of the monolith, or should we separate it out, make it as a microservice? I think that's more a question of like whether to make or not. So if you look at again the problem statement, we need to make it as a public version, right? Now if you look at what is a public version, what would happen? You cannot really, you could estimate, but realistically it's very hard to predict the demand of scaling how much it would be compared to other user. Because typically in a sales process, there is obviously some cycles that people will use, right? So 100 users is a typical user base, let's say we have. Globally, it may not every time it will overshoot to 1,000 every day. It's very hard, it's very unlikely. But in a public version, you will never know, right? Maybe there is a promotion going on. I mean, it's just, you can just try out. So the decision here, what we investigated and what we understood is that there is a possibility that the overall scaling of the application, maybe it is not required to match everything. Because my monolith had, or my modular monolith had various other functionalities. If I have to scale only this one service, I have to scale everything, right? You need to put multiple boxes. That may be not a good solution. So what we tried to do here was we took up that the pricing service, what we used to give the pricing, we created a separate application for that, and we deployed that to cloud, right? So that one particular application was completely independent from the other application. So that application could scale up 10 times more than your, the platform itself. So I'm separating out the one of the services platform and putting it as separate. Now, the moment I do that, I need to have separate code base. There was a separate team created for that, and there is a separate deployment. It has its own stack, its own life, right? It's not part of your main application. So that is very important, because unless you do that, you don't get the benefits that's associated. I could say that this is it's already a microservice because it is returning a JSON format, whatever. So you could use it for public API. That is not the right way to do it, because then what you are trying to do is you are trying to make the monolith scale, right? You are not making the microservice, pulling one out and scaling that. So in my observation, or limited observation rather, but talking to people as well, found there are two primary reasons why you would go for a more microservice, multiple small application to solve a problem, solve any business problem. One is the business context. Now, that can be a very wide term. Let's say, an e-commerce is a business context. Now, there is a good book written by, that's Domain-Driven Design, written by Eric Evans, maybe you might have known, where he defines what is called as a business context. So, he defines context, or the term is bounded context. So, what he says is that you talk about, let's say, e-commerce, it has many modules. If you are a very small company, you are doing, let's say, 2 people company, you do everything yourself, you don't have any different business context. Maybe you will only take the order, you will only, packages, you will only ship, and you will give that to the customer, you will do the delivery. Now from that context, I ask you, are a e-commerce, your business context is only one, right? There is no separation. Now, there could be another company, they have thousands of employees, multiple warehouses, large company. For them, e-commerce is a very large context. I mean, it's unable to somebody to understand what it is. So for them, order fulfillment may be a business context, right? So you rather talk about order fulfillment needs to be separate from the rest or not. I mean, that's how you think in terms of design. So
in this book, he argues that everything has a bounded context, and then you need to communicating with the context. It should be separate. So it's a good book. You can read the concept. So what I'm saying is that you could use a similar concept, to see how separate it is from the world, other world, right? So how separate it is different from the stakeholder. Now, stakeholder group is important because if you, let's say, look at in the e-commerce, you are talking about user registration, for example, right? Tomorrow there is, let's say, a change in the privacy laws that's saying that you should use so-and-so architecture to store if it's a name or email is involved. Now, that could impact your application design. So, to which user you are interacting, which group of users you are interacting, your application supporting is also very important decision maker in terms of how you would define an overall architecture. So that's why I'm keeping as that's one of the decision makers. Application/team size, that's also very important. You don't want one service or to be maintained, or rather way, all these microservices buzz was coming up, like Netflix is implementing, Amazon is implementing. People ask questions like, what makes a microservice, right? How big is the team? So, and people, I don't remember the name, but they tried to talk to all these folks who are running, and they figured out that most companies where they have did it successfully, one service was maintained by like all the developers you could feed with a pizza. Now, that's an American pizza. That's like a big pizza if you've been eating. So, for them, it was like 8 members. Okay? So, which means that one service typically needs to be maintained by 8 people. So, you can just try to calculate in your mind. Anything that you cannot manage, or any source code you cannot manage with 8 people of team, then that needs to be a split. Right? That was the decision they made. In the company, and looks like it's obviously the average. That's a good cut to make, because as we also know, with Agile, Scrum, and with our own experience, there is a limit to which you can scale teams, right? If you add more than that many members, the team just breaks. I mean, it's really hard to communicate. So one team needs to have one microservice, is what I'm saying. It cannot be that there can be like 9 services that is managed by one team. Then you would rather create that as in one application, unless you don't have other criteria of the next point of whatever scaling needs and other stuff. But typically that is the guideline, what at least I use and I've seen people suggesting. Second point is relative scaling. Now, scaling itself it does not make qualified to be a microservice. Let's say that your application is heavily used, everybody is using it, right? Kind of thing. Now, you don't need to be a microservice for that, because you could scale it, write application in using the technologies that would scale and everything. There is no real need of splitting it up. But if there is a difference in the need of scaling, like certain features of the application need significant different scaling needs than the other side of the application, then if you put everything, obviously you need to support the highest peak demand, right, always. So if you put all the application to the peak demand, you are consuming the compute and memory services for the complete application, which may not be required. So that's why I'm using the term called as relative scaling, if there is a significant difference in between the scaling needs. Now, second is that impossible to use the same deployment unit. Now, what do I mean by that? It could be because of technology, it could be because of various reasons that you cannot deploy these things together. So I would suggest rather you split it up separately, make it microservices and run. So these are high level the 2 reasons that I find mostly to see why you would need to go for a microservices rather than a modular monolith. So don't write a monolith as a monolith, as a big ball of mud kind of thing, right? Go use all the engineering practices you have, modular monolith, modular packages that would help you reach that level. So last slide I have, and then we'll go to the questions. And I really like this slide from Martin Fowler, and he wrote a lot about the microservices, and he have seen obviously the peak and it's fading, what it takes. So if you really look into the slide, is your productivity, the other as you have complexity. The green line is the monolith and the yellow line is the microservice. If you think about it, in the starting, monolith would always be, for the application that is a similar complexity, and you can see the complexity is increasing. In the beginning, if you see, for less complex systems, if you go with a microservice architecture, there would be a extra baggage, right? That would reduce the productivity. If it's a small application, what we call as a less complex systems, it would always be better for you to start with a monolith, right? As you have more and more complexity, you stay with your monolith. That means that you started a team with 4 developers. You're adding more and more features. You have no way of removing people. 4 more people join. Then again, you need 4 more people, let's say. Then you try to split the team. But you're not able to split the application source code. I mean, they're still dependent. Your productivity will go down. Right? At that time, or in similar situation, if you could have started with microservices, there is a possibility that you will keep the same productivity because you are not dependent. So that's this graph. You can read this article online, and it's really good take on what to do and what not to do. At least it gives you a kind of relative understanding of what are the benefits, what are the things you should take care of, right? But most important thing is in the last line where he says about whatever you do, whether it's a monolith or a microservices, the skill set of the team will outweigh any choice. It doesn't matter because you use some architecture or not use other architecture, whatever, it doesn't matter. Because the skill set of people who are doing, the engineers you have in your team, your colleagues, and all of us as a community, what we do will outweigh everything else. So that is the most important thing that we should focus, right? And I mean, that's not in the slide, but Fowler goes on to say that when you are not sure, it's almost every time safe to say that start with a monolith. So he has another article that says that start with monolith. So you could read that as well. So in which he argues that, if we are not sure what we are doing, where we are going, it's always better to start with a monolith rather than starting with the microservices. Because the moment you start with the microservices, you need to have so many components or interaction with the components. How does that work and the things? So it removes all those dependency. So that's a real advantage. So yeah, any questions at this point? Yeah.
So when you start with monolithic, and then basically, can you use it? Have you seen any sort of scenario where you have used API gateways to actually scale your monolith into microservices? Like you have all the transactions and the order, which is the order, and then you have the user base. So you have the same code base with the same stack, but you deploy it in different servers with the API gateway, simple API gateway. That can be like a transition part or something like that. Have you seen some sort of scenario?
No. Most probably that is possible to fail. The moment you have the source code in the same tree and you are in a situation where you can pull it out. Typically, let's say you realistically think of it today, how much time it takes to create a Hello World application, right? Today it's very fast. So realistically speaking, within a week or days, you should be able to slice that out and create. So if you remember the slides, let's say here, you want to create an orders microservice, right? It should be, keeping in mind that you are using the same tech stacks and there are less dependency between the modules, it should be relatively easy for you to slice out and create a separate source code. Why I'm saying is that only deploying that may not be that successful is you always have a dependency on the other part. So API gateway, as it is, it gives multiple APIs within the same service. So at least I have not seen, or I have no idea how do you scale that only one application and out. So if there is a need to go, and that's what we have done in one of the services, we've taken that piece out, complete piece, we put it as a separate unit and we deploy it. So that now it's its own, it's an independent.
So like if the stack is different definitely this microservices is possible. But my question was like, if you want to like scale only just one thing, can you experiment on that and then probably transition the complete microarchitecture?
Yeah. So in my experience, I've not seen that working. Is my answer. But it could be. I mean, there could be other innovative way to do that. But at least I'm not aware of that. Yeah. Okay. One second. Let's go.
So you mentioned the book by Eric Evans.
Mm-hmm.
He mentioned something like primary context and secondary context.
Mm-hmm.
So, for example, user management might be a secondary context in some domain.
Yeah.
Now, that kind of a service does not change very rapidly.
Mm-hmm.
Although you need it and you need it to scale separately.
Yeah.
As the number of users grow.
Mm-hmm.
So, do you think, and there will be supporting secondary context as well,
Mm-hmm.
bundling them all together
Mm.
and creating a monolith for that and deploying that as a microservice is a good idea?
Yeah. You know the best answer for any question, right? You guys know? It depends. That's the safest answer I can give because, I mean, see, what we need to realize is one of the ways we all have job is because there are no ready-made answers, right? because we need people to think and evaluate various criteria and come up with an answer that will suit. So I don't think I have an answer for your question. We need to see. But one way to look at it is that if you have a module that kind of works at multiple regions, multiple domains, what do you do? I think you brought the right example of user management. Right now, you know that most applications does have an identity management completely kept separate, right? If you see, let's say take an example of Google. Whatever Google application you use, you go somewhere and you. So that is in a way is a microservice because all your login and password is kind of stepped in that system. So yes, if you go with the microservices, maybe keeping it separate and communicating would be a good option. It's in general advice I can give. But yeah, it really depends on the context it is. For example, one of the big challenges that we are facing right now, so we have thinking of making all our kind of reports separately in a kind of reporting system. So one of the challenge really is that there are a lot of these common things, what we call as, let's say, countries, regions. These are really tied up to every individual, right? So how do you make that separate? I mean, do you duplicate? Do you keep it too close? I mean, this is a normal challenge you would face, and that decisions you need to take in a case-to-case basis. And you need to live with the consequence of the decision. That is more important. You need to make an informed choice. You know that you do this is what will happen, and things like that. There is no point complaining after you make it to database. There is no point complaining these are not in sync. It would not be in sync, right? That's given. So you should know that consequences before you make the choice. Yes, sir. Yeah.
The second thing is, have you seen occurrences where people have split features into microservices and then they had to merge them back? Is that a phenomenon which happens at all?
I don't know about the second thing, and even if it happens, most probably people will not speak about that. So, yeah, right. So, correct. Yeah. Yeah. Yeah, so I think answer your question, performance is one of the major reasons. I think that, so if you remember, go back to my original slide on the 3 or the 2 primary reasons. Because there are front ends are more powerful, you have a way to communicate with multiple services. If that was not there, if you are developing in JSPs, you would never had the microservices, right? Because there is no way you can communicate. So yeah, performance is a reason to go for that. Yeah, but I don't know if it's separate microservices, coming together. But if you use separate tech stack, if you use separate source tree, if you use separate, technologies, I think you need Go's special lands to kind of combine them. So it would be almost impossible to combine. It would be my answer. Yeah, so you have.
So what will be the best approach according to you to maintain data consistency between the different services?
Yeah, there are many approaches. Again, I've answered the question in the previous, the same answer, it depends. You could read about eventual consistency. There are a lot of strategies what people use to do that. But I don't have a kind of ready-made answer to that.
Is kind of described with like two-phase commit protocol or like it's separate because microservices violates this?
microservices doesn't really say what you should do if there is a problem. So, they ask us, like, as a developer, you need to figure it out. What works best for you, right? Let's say you're running a sale, you have very vaguely put, let's say there is only one stock of item available to you, and 2 people are going. So this happens a lot with airlines. So you know overbooking of airlines, right? So most probably the airlines will be overbooked because they don't block the seat for you. Rather, there is a pool of seats that anybody can book. So what they do is they expect people, somebody will cancel till the last moment. And if nobody has cancelled, what they do is in the airport they will announce, like they'll give a hotel, dinner, whatever it's that day if you travel the next day. I mean, they do it on purpose because they don't want to, the moment you go to the booking process, the probability of you complete the process is very less. So what they will do is whoever want to book, let them book. Whether they're traveling at that time, we'll see whether seat is there in the airplane or not. That's a strategy the airlines will use. So you'll always, most probably, get the seat. Yeah.
One of the recurring theme I see is that microservices are increasingly used in the e-commerce platform. Is there something to do with that it's easier to have separate bounded context in e-commerce than in typical enterprise land?
Yeah. That's exactly the reason. Even I normally give a speaking and check in my blog on the, actually what is microservices? Even I have the slides on e-commerce because it's so easy, right? Orders, your e-cart, I mean, it's so easy to communicate. So that's why it's mostly used there because it suits the domain more. But it is used in other places. Like I've mentioned to you in my use case where this is not really an e-commerce instance, but this is a separate product and its own configurator. That context also it is used. But mostly I think it is in the... So there is a technical call you need to take. How much is the interconnectivity of the business? So, and it's a business interconnectivity. Many times, even though it's not really a technical challenge, but if there are like separate stakeholders involved, it's rather to kind of separate it out. So again, sorry to have not say that, I don't have a ready-made answer, but typically you will not have, if you have like too many interconnectivity, then that would be small in itself, which means that you could do with like one services, right? Let's say you have a company that is running business in one country, then they need to go to multiple countries. Either they would kind of separate the teams, or rather they will, put the same team. So it kind of depends. Right? I think I have 1 minute. Sorry, your question is answered, or you want to kind of repeat? So this sort of.
The same question, like I want to transaction data.
Mm-hmm.
Then how can when it is going to having the transaction in other component, how do I do with the microservices?
You cannot do microservices. Simple answer. Because we need to understand that it's you cannot keep the consistency of data between the two components. Again, I'm not saying for the namesake like you should not do something like that. If you do like that way, it will not give you the benefits that you would normally associate microservices with. So I think with that, I'll try to conclude. So that's it. Thank you for all the time. Thank you for listening. So I'm available on Twitter. You could follow up. Yeah.
We are focusing here modularization. Modules are there. The same modules can be utilized in SOA as well as, let's say, for a microservice. So modularization for service.
Can I come down? I'll come down. Wait. Thank you.
Let me do this. Let me click mirror. Can you try now? All good? Yay, perfect. All good? Here we go. Perfect. Hi, everyone. How's everyone doing? Good, good? Yeah, yay, perfect. So my name is Peter Yaushevitz. I'll be talking about Path to Resilient and Observable Services today. So I'm a consulting member of technical staff. Anyone wants to guess what that is? I'm just a developer. Oracle gives fancy titles to people, so I'm just a developer. I write a lot of code. I work on the FN project. Anyone heard of FN project? Serverless framework. And I also do some presentations now and then. Before Oracle, I spent about 10 years at Microsoft. So I worked on SharePoint, Visual Studio, Phone, and Azure. And now I'm on Oracle. So let's get started. What I'm going to talk about today is not microservices, at least not directly, because you probably heard a lot about microservices today. How many in the room are already implementing any microservices or trying to do anything? Okay, yeah. I mean, everyone is saying they're doing microservices, so it's a mute question. So I'm not going to spend too much time on explaining about microservices. I'm just going to show you some examples and some things that you can keep in mind while you're implementing microservices, and some tools that you can use to make your microservices more resilient, and I'm going to show you how to test them as well. So the first thing you're going to notice when you start moving from monolith to microservices and breaking it down, that previously you had one problem, now you have 4 or more, right? And not just because you have 4, you also have multiple instances of those microservices, so you have a lot of problems, right? Previously it was a single code base, it was single deployment. Now you're doing multiple deployments, multiple code bases, your problems are just getting bigger and bigger, and everything needs to work together perfectly, right? In addition, there's, as I said, multiple instances of everything, which makes everything even more complex. So with so many instances, you need to figure out a bunch of things, right? So how are you going to deploy all your instances for all your microservices across multiple machines? How are you going to do that? Well, you can SSH into each of the machines and then do the deployment manually, but I don't think that's going to work perfectly. So what you need is you need an orchestration tool, which is Kubernetes for orchestrating and Docker for packaging your services. Anyone heard of Kubernetes and Docker? Yeah, perfect. So I'll be talking about Kubernetes, but not directly, just like with microservices. So, so Kubernetes and Docker will take care of your deployments, and they'll make sure that your services are evenly distributed across all the VMs that you have. Kubernetes will also give you the ability to do health checks, meaning you can implement a health checks on your service that's going to tell Kubernetes if your service is healthy or not. In addition to health checks, Kubernetes also gives you the ability to do service readiness checks. So the difference is, with health check, if service is healthy or not, with readiness check is basically saying that if service is ready to receive requests or not, right? And on top of that, Kubernetes will also automatically restart your containers if your services fail. So this is really nice, right? So your service is failing, but it's crashing, but the Kubernetes is restarting it, so it's all good, right? Well, not really, it's not, right? Maybe it is a little bit, but it's really not. So what you really need to achieve is to make your services resilient and observable, so you're gonna know when something goes wrong. So what is resiliency? So these are the two out of many definitions that you can find on the Wikipedia and internet. And it's basically telling you that resiliency is the ability to provide and maintain an acceptable level of service in the face of faults and challenges to normal operation, or is the ability to recover from failures and continue to function. So it's not necessarily about avoiding the failures. It's more of a responding to failures in such a way that there's no downtime or data loss. A simple goal of resiliency is to return your service to a fully functioning state when the failure occurs. And the failure will occur, right? There's no doubt about it. So let's talk about the two aspects of resiliency. One aspect is the high availability. And this one is basically talking about service running in a healthy state. It means that there's no significant downtime to your service. It also means that the service is responsive because your users are using it, so it has to be responsive. And it also means that it's meeting the SLAs, service level agreements, right? The next aspect, the second aspect, is the disaster recovery. So I'm not going to spend too much on disaster recovery, but in short, disaster recovery is all about how you recover from like rare, very rare, hopefully rare, but major incidents. It involves data backup and archiving of data, right? You can also say that disaster recovery starts when the availability, the high availability design can't handle failures anymore. That's when you start, that's when you're in a disaster recovery mode. So what do you need to do to get to the path to resilient services? First of all, you need to understand the requirements. So how much downtime can you handle, or how much downtime is acceptable for you? And this is different for everyone, right? Like downtime for Amazon is probably different as a downtime for my side project, right? It's usually related to cost, right? So more downtime you have, you're probably breaking SLAs, you have unhappy customers, and it's costing you a lot of money. The second thing is you need to define what does it mean for your service to be available, right? So is it the simple website is up and running? Is that good enough for you? Or you also need the purchasing mechanism to work or any other components to work as well. So you need to define this for your services. Next point is designing for resiliency. So this comes into play once you have your architecture set up already. You need to go in and you need to figure out what can go wrong and how can it go wrong. So you basically identify the points. The next point is the strategies for detection and recovery. So how are you going to detect the failures and how are you going to recover from them? So you need to define that up front and come up with some strategies. So you need to ask yourself questions such as how will the service detect the failure and how will the service itself respond to the failure, and how are you going to log and monitor for this failure? So you'll also need to define all of those things. Like, for example, if your service is unavailable, you will return a 500 HTTP status code, right? If the caller of the service is unauthenticated, you'll return a 401, etc. So next one is testing. So testing is really important, right? Without this, like you can't ship anything today without testing, because you're just going to make a fool out of yourselves and people will laugh at you. But what's especially important with resiliency, you basically need, it's not the normal unit testing. You're not testing for functionality. You're testing for failure conditions. So you need a way to simulate failure conditions and then see how your services react to it to be able to detect and recover from all those conditions. And since you're doing all this, you of course need a way to monitor everything. Because if you don't have monitoring in place, you have no idea what's happening, right? You're just flying blind and crossing your fingers and hoping that all is good. So next I'm going to talk about some resiliency strategies. First one being load balancing. So load balancing basically means that you can have one instance of the service and you can add hundreds and thousands of more instances, and the load balancer will make sure that the load is evenly distributed between across all the instances. Next crucial element is our timeouts and retries. So network introduces a lot of unpredictable behavior, and one of them is being latency. So how long do you need to wait for a service to respond? Anyone knows? What's the magic number? So there's no magic number. It's a trick question. There's no magic number. It's you have to have a timeout set for everything, because if you don't, you're just putting strain on your system unnecessarily, right? There's always someone waiting on that call to happen to get a result, right? And if that thing is waiting, it's eating up resources. There's another thing that's probably waiting, eating up even more resources, and all of a sudden you have cascading failures. And that's not good. You don't want to do that. So you always make sure that you have some timeouts in place for all of your calls. Even when you have the timeouts in place, it's also important to do retries, right? So retries is like, I always think about retries as gambling, right? It's like you try once, you're going to lose, but what if I try one more time? Maybe I'll win, right? So similar with retries. Always try. I'm not saying you go and gamble, right? I'm saying always try at least 3 or 5 times, right? Or a couple of times to make sure that maybe there's like a network glitch, and then the next time you call it, it's going to be all good, right? The way you wait or the way you retry is you can use like a constant value that you wait between retries, or you can do things like exponential backup, for example, right? Where after each retry, you're waiting longer and longer, right? All right, next strategy is circuit breakers. Anyone heard of circuit breakers? Anyone from the electric engineering knows what a circuit breaker is, probably? It's very similar. So I mentioned the cascading failures that can occur. So what circuit breaker pattern does is you can use it to prevent additional strain to the system. So with a circuit breaker, you can encapsulate your service or the functionality, and then you configure a certain threshold, right? You say, I have service A, and you define a threshold that says, if the service fails 10 times within 5 seconds, right, you're going to trip the circuit breaker, right? Once the circuit breaker trips, that instance of the service is going to be excluded from the load balancing pool, so none of the requests will ever reach it anymore, right? And of course, there's another value that you set, 5, 10 minutes, whatever the value is, when you can bring the service back in, and then if it starts failing again, you repeat the whole thing again. So that will prevent like additional strain to the system if something is failing. A bulkhead pattern is very similar to a circuit breaker. With a bulkhead pattern, you're just isolating critical resources. So if services that are failing in your accounting system, if they're failing there, they're not going to bring down your ordering system, for example, right? Next point is data replication. So there's a general strategy for handling non-transient failure in data store. And data replication is usually like built in major technologies that are out there already. So, all right, graceful degradation. So this one is an interesting one, and it's very user-facing thing. So if one service fails in your system, it should still continue to work. Like the whole system should still continue to work. Anyone knows Amazon? Probably, right? Amazon.com. So if you go to Amazon.com, there's a recommendation portion of the website. So I'm assuming they have a service behind it that serves up the recommendations based on the books you read or the stuff that you bought, right? So if that service goes down, do they ever show you like an error page? They don't, right? So they gracefully degrade the service and basically show you either cached data, right? Or they don't show you anything, and you're probably not missing out on much anyway, right? Next time, or once the service comes back up, you'll see it again. So you need to like degrade gracefully, right? So you're not like bringing down the whole system. Final thing here is rate limiting. So you have to make sure that you're rate limiting requests that are coming into your system, because you don't want certain users like producing excessive load onto the system and bringing everything down. So the most important question, right? How do you do all this, right? It's nice to talk about it in theory and everything, but how do you do it in practice, right? So I'll talk about service mesh. Anyone heard about service mesh before, service meshes? Okay, so this is one way to do it. It's not the only way, and it's not the best way, so it's one way to do it, right? So let's start with a service mesh. It's probably very popular, just like the microservices talks are. The definition says that service mesh is a dedicated infrastructure layer for managing service-to-service communication to make it manageable, visible, and controlled. So if we pull the gist out of this definition, it's all about communication, right? It's all about how the services communicate between each other. So if you look at the left side, we have 3 services in this case, and they're all happy and they're all talking to each other directly, right? On the right side, we have a service mesh that injected a proxy next to each instance of your service. So in this case, services are not talking to each other directly anymore, right? Everything goes through the proxy. So any incoming or outgoing calls from the service will go through the proxy. So it's the proxies that talk to each other. In addition to those proxies, there's also the service mesh control plane. And the control plane is the system that manages all these proxies and controls them. So you can come up with high-level rules. Let's say you want to apply 6-second timeout, whatever, to all of your services. You're going to create a rule. You're going to apply it to the control plane. Control plane will translate those rules into configuration settings that the proxies can read. It's going to push those settings to the proxies, and proxies will automatically reconfigure themselves and obey those rules, right? So I'll talk about Istio Service Mesh. Istio Service Mesh uses a model called sidecar pattern, sidecar being the proxy that lives next to the service. There's also a bunch of other service meshes out there that either use the same model or they use a per host model. So the difference is with sidecar model, you have one service instance, you have one proxy, right? So if you think about it, if you have 100 services, if you have 5 instances per service, you're also going to have 500 proxies next to your service, right, to each instance. So it can grow like, it can eat up a lot of resources, and it can be very resource intensive. So the other model, per host model, is, I'm talking about Kubernetes, right, in Kubernetes world. You have a proxy per node. So you have one proxy that runs on each node, and then services that are placed on that node are talking to that proxy. Proxies still talk to each other, right? The only difference is you have one instance per node instead of having an instance per service instance. instance per service instance, yeah. So at a high level, this is how it works. A great benefit of a service mesh is that you can push certain functionality out of your services and into the proxies. So for example, previously, you would implement timeouts or retries or things, or like HTTPS SSL connection. You would implement it in your service, in each of your service. Right now, you don't have to. You can push it out to the proxies, and proxies will do everything for you, right? You just apply the configuration. It's all good. You don't have to do it in the service anymore, since the proxies are the ones that are talking to each other. So let's go back to this slide. So these are the things that service mesh can help us with. So load balancing, timeouts and retries, circuit breakers, and rate limiting. There's also other things a service mesh can do, traffic management and security being one of them, but I'm not going to talk about this in this talk. All right, quickly about testing. As I mentioned, testing for resiliency is not the same as running the unit tests. You basically need to test how your services perform under failure conditions. High level, 3 steps. You need to test, you need to measure, and you need to analyze the results. Anyone knows what you do after that? You go back and you test again, and then you analyze, and you keep repeating that until there's no bugs anymore, which is not going to happen. But so what Service Mesh can do here with injecting the failures and testing is there's 2 resources. Well, there's 2 ways that you can inject failures. You can inject delays into your service, and you can say, I want this service to respond after 6 seconds, right? Or it's going to take 10 seconds to respond, or 15, or whatever. And in addition to that, you can say, I want this service to respond with a 6-second delay, but only for 20% of the incoming traffic, right? So it's very flexible. Similarly, with faults, you can say, I want this service to return pick an HTTP status code, 404, 30% of the time, right? So that way you can like inject a little bit of chaos in your services, and then you do the tests, and you measure, and you monitor, and you see what's going on and how your system is behaving. So let's talk about observability a little bit. So quickly, the definition, it's just the act of measuring, collecting, and analyzing different signals that are coming from your services. It is very crucial for resiliency because you need to know that something failed, and you need to have enough information to figure out what caused the failure, right? So it's almost like observability allows you to investigate stuff and see what's wrong. There's multiple parts to it. You need to instrument your services, so your services need to emit metrics. Then you need to collect those metrics, you need to store them somewhere, and finally you need something to visualize the data, to analyze it, visualize it, and potentially alert on any of the data that you're getting in, or metrics. So in order to be able to successfully investigate things, I listed a couple of good practices that you should be following. First one is correlation IDs. Basically, every time there's a request coming into your system, you generate a random and unique correlation ID, and that ID gets passed to every other service that service calls, right? So if you're doing proper logging as well, you're going to have that correlation ID in all of your logs. Second point, structured logging. Make sure that logs are machine parsable, even better than having it human readable. I'm not saying go with the binary format, right? But make sure it's like JSON or XML or something, because it's always easier to parse the logs with a machine and make them readable than going the other way around, right? Private information, this is like a no-brainer, but we still see people doing that. Make sure you're not logging any like credit card numbers or social security numbers and stuff. It's not good. Unique metric names, this is one of the practices where you do like company name plus component name plus metric name, just so you don't hit any collisions. Categorize your log entries. Start with like info level, debug level, warning level, however many levels you need, but start with at least one so you're not overwhelming yourself. Common format. One thing with the common formats, make sure before you go and start implementing a bunch of microservices and everything, one thing you need to make sure is that everyone is using the same time format and the same time zone. Because if you're not doing that, then yeah, just you're going to spend your time parsing logs and figuring out what happened when, right? Finally, context matters. So ideally, with each log entry, you should know which service logged it, which Docker image was used, what was the host ID, application ID, whatever you think it makes sense to help you. So a couple of tools I'm going to mention, and then we'll go to the demo. So one of the tools for collecting metrics from services is called Prometheus. Again, talking about Kubernetes, Prometheus runs on your nodes, and what it does is it scrapes, it calls your services and asks them for any metrics. Do you have any metrics? Give me some metrics. Takes the metrics, stores the metrics, right? Practically, in your service, you implement a metrics endpoint, and then Prometheus is going to call that endpoint at a preset interval, a couple of minutes, or whatever you set it to, and it's going to collect the data. And it can do like counters, gauges, histograms, just different data types that you can log. Once you have all these metrics collected, you also need a way to show the data and visualize it somehow. Grafana is the extremely popular tool that allows you to create dashboards and graphs, and it looks really nice. It has a bunch of plugins, meaning you can plug in the data from Prometheus or plugging the data from probably hundreds of other data sources. Jaeger, so Jaeger is another tool that's used for distributed traces. So this is one of the tools where you can use the request IDs and see the traces, how the traces flow, and how the calls flow through your system. EFK stack, Elasticsearch, FluentD, Kibana. FluentD is like functionally wide. Like the simplest way to explain FluentD is it's like Prometheus, but for logs. So FluentD is going to go and get all the logs from all of your containers. It's going to collect them, put them in Elasticsearch, and then you can use Kibana to do the searches and go through your logs. And finally, this is the worst one of them all. Anyone knows the PagerDuty? Yeah? So for those of you who don't know what it is, this is like an awful place, an awful website that you go in, you give them your phone number, you give them your email address, and then if anything goes wrong, like in Prometheus, you can define an alert and say if the response, if there's more than, I don't know, 500 responses in 5 minutes, it's going to fire off an alert. And then PagerDuty, what it's going to do, it's going to call you at 3 in the morning. It'll wake you up, and then you'll have to go and fix the issue, right? So it's a nice tool, but I don't like it too much. All right, demo time. I'm so glad that this is all working so we can do the demo. So I'll show the resiliency features, timeouts and retries, and I'll use HTTP delays and aborts to show you how you can test the service. And then the observability part, I'll show the Jaeger and Grafana. So let me explain the simple demo that I have. So I've created 3 services: weather service, city service, temperature service. So you can guess it's all about the weather, right? So you call the weather service, you pass in the zip code, and the weather service is going to call the city service. It's going to return you the city name and state. I don't know why I added state, but guess what? You're getting a state as well. And then you call the temperature, and it's going to return you the temperature, right? So you're going to get like a JSON response that's similar to that one down there. All right, now the moment of truth, and let's see if this works. Yay, perfect. All right, so let me show you. Can people in the back see the thing? All well? Perfect. All right, so I'm going to show you. I have 3 city service instances. I have 3 temperature service instances, and I have 3 weather service instances. And all this is running on my machine locally, right, on Kubernetes cluster. So if I make a simple request with the 98052 zip code, which is Redmond, Washington, that's where I'm from, I get the city name and state, I get the temperature, and I get the zip code, right? So let me go here. Let me quickly show you Grafana. It's going to look a little bit ugly, but because of the resolution. So Grafana comes pre-installed with Istio. So what I did is I installed Istio. I got Grafana, Jaeger, and the service graph for free. I didn't have to do anything. Any of these dashboards, this was all installed automatically. I didn't have to do anything. So let me show you the performance one. So this one is just showing the performance data, and to be honest, it doesn't really make sense for this demo because I'm running the cluster locally, so it's one node. Doesn't really matter much, but if you're running it in production, this would matter, right? You could alert on this and see how much CPU is being used in memory, etc. By the way, all of this, I'm using Docker for Mac. You can use Docker for Windows. You can use Minikube. You can go to Oracle Cloud. You guys got like $500 worth of credits that you need to burn, right, and use. So you can go, you can create your cluster, you can install all this. It's going to work exactly the same way that it works here. So, all right, so before I continue, let me go. No, not this one. So mesh dashboard. OK, so here's my weather service, temperature service, and city service. There's also these 2 that are like Istio-specific components. And to be honest, I have no idea what is this one, right? So don't even ask. So I'll go back here, and I'll do this. I'll start sending continual requests to the service just so we can get some data generated, so we can see some actual things. So I'm sending that request every second. So let's go back here. Let me refresh here. And all of a sudden, you see that it has already changed. It's green. Success rate is 100%. It shows me the operation per second, right, how many requests I'm making, and the latency. So if I click on one of the services, I get similar information here. Client success rate, operations per second, server success rate, like different. This was the first request that I did, right? It was 200, and this is the continual request that I'm making right now. Jaeger, I'm going to show you this one as well. So this is distributed tracing. Let me just see that I don't have anything. All right. Can I do this? Is this better? Oh, perfect. Looks better. All right. So Jaeger basically shows you how the calls are being made through the system. So from this one, we can see that the weather service, right, called the temperature service. And you get some information here. What was the user agent, right? So my services are written in Go. They could be written with anything else. Status code was 200. This was the URL that was used. And this was the request ID. The third thing that gets installed with Istio is the service graph. So let me refresh this one. All right, there you go. So the ingress gateway is the entry point to my cluster. This is the local host, pretty much. And then the local host then routes directly to the weather service. And then weather service is making requests to the city service down there and to the temperature service. And all of these services are also talking to Istio policy and telemetry services as well, right? So this will give you like a nice quick snapshot of your system, right? All right, and now I'm going to look at the cheat sheet here and start doing some actual stuff. So we have everything running. Everything is all in nice. So let's scale down the city service to 0 replicas, right? So there's no city service anymore. It's down, right? You can see already up here that there was an error getting a city. I still got the temperature, but I got a 503, right? So I go to Grafana. And I'm going to go to the city service. You already see that 85%, right? The client success rate is going down because the service is not there anymore. Same thing here. You're seeing we're getting 503s being returned to the weather service. So something is clearly wrong. Success rate is all down, right? Similarly here, if I go to Jaeger, I could do status code 503, and this was a few seconds ago. So this will also give me the same information, right, 503. Now, I know this is a very simple, like, 3 services demo, right? But imagine if you had, like, 10 of them or 20 of them, right? This would be, like, extremely helpful, where you can just go and figure out who called what and where was the thing failing. All right, let's go back and make it healthy again. So I'm going to scale it back up to 3 replicas. So if you wait a couple of seconds, let's see, the pods should be coming up. So they're initializing. I hope the Wi-Fi is going to survive, and they'll come. Of course it's not going to work. All right, let's try again. We can still show the other demos, I hope. All right, so it's initializing. Let me try real quickly. Let's do this one. I'm betting is the Wi-Fi is not. Yay! So it's back up finally. So you can see the responses are already coming back. If I scroll back to this one and refresh, we should also see. There you go. So we see the 200s are going up, 503s drop down to 0, and the success rate is going to go up as well. It's going to rise all the way to 100, right? All right, let's look what's next. So we did the 3 replicas. So what I'm going to do now is I'm going to introduce a delay to the temperature service. So this is how, I don't know how many of you are familiar with YAML in Kubernetes. But YAML is pretty much used to describe the Istio rules. So what I'm saying over here is I'm saying I want to introduce a delay for, it's hard to read, 100% of the time, 100% of requests, and delay it's going to be for 6 seconds, right? So let's apply this one. So we applied it. So now if we go back, and this was the temperature service, right? So temperature service, let me actually zoom in on this one, it might be easier. There you go. So you see over here, it was like 50 milliseconds, right? And then boom, all of a sudden, it's picking up that delay. So what this gives you the ability to, let me apply here, to see how your services are going to react, right? So you think about, and this is just a simple YAML file, right? So it's parsable, it's scriptable. So you could come up with a script or a chaos monkey that's going to randomly put it in your cluster. It's going to go there and like bring stuff down, insert delays and stuff like that. And then you can observe it and measure it and hopefully find some bugs that you can fix later. You also see that the request volume has dropped, right? Because we're waiting for 6 seconds. So let's make it all good and reset it back. All right, so it's all back. So this should start recovering again. The request volume should go up. Oh, also Jaeger, we can see this here. So I'm going to delete this. And over here, I'm going to say 6 seconds, right? Show me anything. Oh, let's do 5, right? Show me anything that was more than 5 seconds. And there you go. There was the one, right? Temperature service. It also shows the one of the downsides with Jaeger is it's also going to collect the traces from the proxies, right? So it can be kind of noisy. Yeah, see Istio Mixer. Let me see if there's one. Yeah, this one was 6 seconds, right? So you can see the duration was 6.03 seconds, right? I guess the 0.3 is the amount of time service took to respond. All right, so we made it all good. Now I'm going to do something similar, and I'm going to show you an abort. So it's the exact same thing as with the delays, but in this case, I'm going to introduce a 404, and I'm going to introduce it 60% of the times. So 60% of the requests that are coming into the city service will respond with a 404. So let's apply it. There you go. And then over here, you should already see, there you go. So there was a 404 fault filter abort, right? So, and this is without, like, I haven't touched the source code at all, right? My services are right, I haven't touched anything, right? It's just all configuration. If we go back here, I think you probably trust me by now that this is going to show up somewhere here. So in case it doesn't work, but yeah, you can see the weather service. Let me click in. It's easier to see. So weather service 404s, right, on the rise. So it's clearly it's working. And then same thing here. We could do status code equals 404. Let me remove this one. Traces. Okay. Let's see. There you go. There was a 404 here, right? All right. Let's reset these back. And we have 7 more minutes, so we're perfectly on time. So I'm resetting everything back, and I'm going to show you one more thing. So now we're going to show you the retries and timeouts. It's a bit tricky to simulate this, so you're going to have to trust me a little bit, but there will be a proof in Jaeger. You'll see that retries will actually going to happen. So what I'm going to do first is I'm going to introduce a 2-second sleep to the temperature service. So what this is doing, this is setting an environment variable in my deployment, and then my service is reading those 2 seconds out, and it's saying whenever there's a request, I'm going to sleep for 2 seconds first, and then I'm going to return, right? So we did this. We also got 503. So let me go back, and I'm going to introduce the retries now. So what I'm going to do is I'm setting a timeout to 2 seconds as well. So we're sleeping for 2 seconds, and the timeout is 2 seconds. So we're going to try to make it fail, right? But then in addition, I'm also saying I want to do 3 attempts with 0.5 seconds in between, right? So we should see 3 attempts happening when the call is going to fail, right? It's going to time out. So I applied this one. So let's wait a little bit. So there you go. So request timeout has already happened. So I'm going to go back. Whoops. Fauna. And we're going to go to temperature. Should start seeing these here as well. There you go, 504. So it's timing out. It looks pretty much the same as it looked before, but Jaeger is going to show us a different story. So let's go here. And let's see if, there you go. So now you believe me that there were 3 retries. You can see, hopefully you can see, does this help more? I don't know, it's kind of odd. Can people in the back see? Or do you want me to, let's do this. I'm going to try and move it so you can see it. Not going to work. Yeah, there you go. So you can see that there was a weather service that called the temperature service, and then it actually did 1, 2, 3 retries. And if you look at here, you're going to see that there was a 504 milliseconds, 504, and 501. So it was like half a second between each retry. All right, let me just reset everything back. Now we can, there you go. Okay, so the service is already recovering. I'm going to go here, refresh it here as well. All right, so we already see 200s are raising back up, and all is good. So this was my demo. I have one more slide, which is this one. I want to thank you all for coming. I'll post, I actually already posted all the files and demos that I have at that URL. It's going to just take you to my GitHub. I think I made it public. If not, I'll make it public. You can email me, peter.yaushevitz@oracle.com, or just ping me on Twitter, add me on Twitter. I need followers. I don't have enough of them. And if you have any questions, we have 3.5 minutes. I'm going to also hang around here for the next 5 minutes if anyone has more questions. Sure.
Okay. These tools are very good to do existing applications. Suppose I want to design a resilient application system, for example. Will this first thing is, will these tools help me to do design?
So the question was if these tools will help you design like a non-microservices system, or?
It can be any system or any application.
Yeah, so,
Brand new application.
yeah, so the thing is, with all the tools that I mentioned, right, you don't have to run them in Kubernetes. You can run them on VMs. You don't have to be using microservices. You can use your monoliths. They're still going to work. So you can still like use this even if you're not doing microservices, because like everyone understands that microservices is a buzzword, right? And everyone is trying to move to microservices. You don't have to move, right? If your monolith is working perfectly, why are you going to move? It doesn't make sense. But the point is, all of these tools, you can use them. You can use them without. You don't have to do microservices to use them, right? But it is if you're starting on a new project, it is good to think about these things ahead. Like think about what do you want to measure before you actually go and implement it, right? Because once you go and implement stuff and then you're coming back to adding measures to it, it's already too late, right? It's good to think about it before you're writing code and then add the metrics with it. And it's just gonna like years ago, when people were not unit testing their code that much, right? They had to get into the habit of, oh, we're going to do unit tests as well. Like today, it's like if you're not doing unit testing, people are like, oh my God, right? It's a normal thing to do unit tests. And I think in the future, it'll be normal to do unit tests, code, and actually think about metrics as well that you're going to bake into your system. Does that answer?
Hey,
Okay.
Peter.
Yes.
Here, last row. Okay, I have a question for you.
Sorry.
It's okay. So all these tools are available in cloud only or in on-prem also?
So this is all on-prem. Like you don't I don't think there's a managed service for like Grafana or something, right? This is, as I said, if we're talking Kubernetes, you can get it on Oracle code, and all this can be installed on a Kubernetes cluster. Right? There might be some managed services. I'm not sure. I'm not aware. But usually the way this is operated is like you have your own cluster and then you're running your stuff alongside in the same cluster. Right?
Okay, thank you.
Welcome. Yes?
See, let's say performance testing tools are also there, right? How do you compare with those tools and these tools?
Performance testing, do you have any specific? So you can use like Grafana and all these tools. If you're doing like performance testing or load testing, these tools are going to help you as well, right? Because you're going to see how your services are responding to the load and everything, right? So it's all like the nice thing about this is you're not like you can remove it if you want to, right? And you can add to it. It doesn't really matter. You're not going to break anything. And as you've seen, I haven't touched any code. I haven't written any code. It's all configuration, right?
I have one question.
Yes.
So you have, in the demo, you have showed 3 services, and through Kubernetes commands, you try to bring them down, and you can show the status codes from the weather service. So in terms of circuit breaker, Kubernetes, we can able to configure it like without touching the code. Like suppose if temperature service is down, and it shows 500, it is not able to take requests. And in Kubernetes, you can able to configure in such a way that if that is not working, then you can give this response.
If you're saying if the service is not working?
Fallback strategy, I'm telling you.
If the container can't start, you mean, or?
No, if the container is down, and at the time the request from weather service is gone, so if it is not able to process that because it tries sometimes, but it didn't get the response from that service. So if that happens, so is it possible to configure circuit breaker through Kubernetes via configuration?
Yes, so I didn't have the circuit breaker in the demo because it's really hard to demo it. But yes, the circuit breaker is defined in the same way as I defined the retries and timeouts. It's all in YAML.
Okay.
You just say, this is my threshold, this is my ejection period, and there's a bunch of other settings that you can set, but it's all YAML, right?
Okay.
Yeah, it all can be configured, no code. I think my time is up. I'll hang around here if anyone has more questions, stop by. Also, there's Woman in Technology session right after this. It's at Indian Durbar. I don't know if I pronounced it correctly. Durbar, there you go. All right, thank you very much.
Bye. Hello, hello, hello. Yeah. Good afternoon, guys. Good to see the hall full, the fag end of the day. It's encouraging for us to continue to talk and share some knowledge with everyone. So, I'm Vishal, and I'm part of the Oracle NoSQL database product management team. Today I'm going to talk about how the cab industry can, cab aggregation industry can probably add some more value-added services to make our lives more easier. So where did this whole thing, come up, or why did it strike to me saying that, there is something more that we can do than just book cabs. So there was this, in fact, it was at Conrad itself. I had a colleague who was flying in from the UK, and we were having a whole day training, a full day right from morning to evening. And I was supposed to reach here at about 9:30ish. The training was supposed to start at 10. So I stay in the other end of Bangalore on Banerghatta Road. And we all know peak hours traffic in Bangalore. It's all over Twitter. It's all over social network to say it sucks. So how did I plan? I spent my whole morning trying to see how am I supposed to reach Conrad. And what did I start doing? I said, okay, let me book a cab. I want to sit relaxed and then reach this place. I booked a cab. None of them are ready to come in because they also know, driving in traffic is going to be hell. I tried metro, and that worked. But then what happened was, as I reached the metro station, there's a huge long queue, everybody trying to take during peak hour of reaching office. And I spent about 15 minutes standing in the queue. So that's when I felt, that was probably the day when the seed got bored in to say, there is something that we should do apart from just booking a cab. So from my home to the metro station, I booked a cab. I reached there, and then I find a huge queue. So yeah, I finally reached Conrad at 9:30 because of the excellent metro network. But then there was some amount of fear in me saying that will I be reaching on time, just because of finding the big long queue at the metro station. Anyway, so let's look at a typical how the cab aggregation industry works. What happens? This is way too simplified, I know. It doesn't look as that simple. So you have customers who can do booking through their web or through their phone. It goes to a taxi service server, and then a cab gets assigned, and you take your cab and reach. Simple, right? I mean, it's as simple as it gets. It's very convenient on our phones, and it does the work. So what else can be added to this? So like I said, my experience of booking the cab, I felt that there can be something more which the cab aggregation industry should do. And what it can do, it can understand me. Why doesn't it understand me while I'm booking the cab? Why doesn't it try to find out what is it next that I want to do? And to do that, basically the entire service which we see right in the middle should actually understand or should have more data about me as a customer, or as any of you as a customer. And how would that be possible? The cab aggregation industry should not just limit itself to transactions. It should probably be able to build more data, more information about a customer. And that's what I will be showing, or probably may not be a full-fledged solution, but a quick demo of what can be done over and beyond booking a cab. So there's a Salesforce survey which said that 76% of customers would want their service providers, and it need not be cab industry, but any other industry, to understand their expectations, to understand the customer expectations and needs. And what do I mean by that? Basically, even without me thinking about what next I should be doing, the service should be able to tell me, this is what you should be doing next, rather than me thinking, okay, now I've booked a cab, what next should I be doing? So that's where this picture talks about, and it says, so this is not something which I have come up with. The 76% is something which Salesforce has done a survey, and it says that there is a big need of today's consumer-related services to understand their customers much more. And how can that happen? I think that can happen not just by collecting customer profile. So is just collecting name, age, gender, education enough? That the cab industry does today. When you download a cab app, you do give in all the information, you give in your birth date, you give in everything that you require. Is that enough for a customer profile? May not be. Relationships, probably the industry should also find out what are the associations which Vishal as a customer is involved with. Is he on LinkedIn? Does he have a Book My Show account? Does he have a Metro card? Does he have a loyalty account with Shopper Stop? And so on and so forth. The list can be endless. May not be. What are his activities? What are the activities that Vishal normally does on social media? What does he tweet about? What does he post on LinkedIn? So today morning I posted about my talk at Oracle Code. So while I booked my cab, if the cab industry would have understood, saying that Vishal is traveling to Conrad to give a talk, what more can it do for me while I'm going prepared for the talk? So social media transactions and social media accounts. So if there is some amount of data which the service can capture about me from my social accounts, excellent. So with all these information is when the service will be able to build more real-time customer insights. It can actually build one big monolithic information about Vishal to say that what is he going to do next, where is he coming from, what is he going to do tomorrow, and what has he done yesterday. Right? So that kind of profile is something if any service provider, and that includes the cab aggregate industry, if they are able to build that, great. Customers like me will be very happy. So let's look at how this is possible. So I'll show you a quick solution architecture about this. I'll try and keep the slides very minimal, quickly walk you through the solution, and then we'll look at some demo, look at some code, see how I've written it, and what technologies I'm using. So I've tried and used most of the open source technologies. And so if you see here, there is profile, there is transactions, there's association, and there is social profile. All of these today in the microservices world are all small transactions which are captured for every customer and stored in their own databases. So the profile information will be stored in its own database. Transactions are stored in their own database. Associations are stored in their own database, and so on and so forth. From these individual databases, if we can stream and collect more information of a particular customer, like what kind of movies he has booked, what kind of metro tickets he has booked, what kind of restaurant bookings he would like to book or he has already done, what kind of events booking. Let's say he's coming to Oracle Code, or if he's going to a meetup, what kind of events he has booked already, and what kind of events he will be attending. Similarly, loyalty management and offers and coupons. So for a customer, we can offer loyalties. The service can offer loyalty bonuses, coupons, and other such kind of loyalties. And all of this gets stored in a NoSQL data lake. So we have all these different information coming in as their own individual documents. And then all of that get combined into one big monolithic data lake And this can be used to build dashboard and analytics for the customer or real-time indicators for the customer. So this is the entire solution, which, of course, this is probably a very simplified version of the bigger solution. But this is how I have built my demo for today. And I'll walk you through the code. I will show you how I'm inserting profile data and transaction data into the data lake, how it gets from its own individual data through a microservice. So I've got a metro booking microservice and the NoSQL data lake of try and see some analytics also. I'll probably show some quick real-time indicators and a few graphs to show what kind of activity a particular customer has done using the service. So in the demo, I have used the primary usage is that of NoSQL database. And why have I chosen NoSQL database? Because it has got, I'm also using child tables. So there is a concept of child tables in NoSQL, which means you can make databases are known for traditionally. But then with this concept in NoSQL database, we can actually, a lot of them open source enterprise streaming solutions. NoSQL has got actually enabled streams on particular, going to be a database table of its own, or it's going to be a different service altogether. And there's also SQL-like query. So if you're well-versed with SQL and you come with the SQL background, it's no brainer for you to get adjusted to running NoSQL SQL queries. Right, so I'll walk you through some code first. I hope people are okay with me running some code and showing some code. So if you see here, I've got about 5 to 6 projects running here. One is called as code 1, where I have all the transactions which is happening. So customer's profile information, social information, all the cab bookings that he has done, all of them get pushed into a table. Then we have 2 microservices, like which I mentioned. There's the movie booking microservice and the metro booking microservice. Then there is subscriber, which is a project which runs streams, which enables streams on a particular table that I want. It reads all the data that gets pushed into the table and then pushes it into a different table, or which is the data lake for me. And then there is render charts, which is basically the analytics part of it. By the way, NoSQL database is available as an open source database. So you have a community edition. You can always download that and use it in your production as well. But then the streaming support and a lot of other features like integration with databases or any other enterprise integrations come in with the enterprise edition. Yeah, so it is a multi-model database. So you can have, the base is key value architecture, but then we've got multi-model support, as in we've got key values. You can model your database as JSON documents, key values, or the traditional table nomenclature, where you have tables, columns with their types and rows. Sorry? We integrate with Oracle's graph database as well. So you can pull data from the graph using the graph API from NoSQL and then show your graph database. It's configurable, so you can have eventual as well as you can have absolute. So when it's absolute, it reads from the master. If it's eventual, it reads from the replicas. Yeah. It's a master-slave architecture, yes. So yeah, I connect to the NoSQL store, and these are the table handlers, wherein you create. So this is where you are actually connecting to the KV store. You get the store handle and then you get the table handle. So table handle and store handle are some things which you would not want to do it on a regular basis because they are pretty expensive operations. In this case, they are all in the same class, but in probably the microservice, I'll show you that I've created a separate class which gets accessed only once. And this is how simple it is to store your data into the table. So I've got, you can see that I'm creating a table for the customer table, and then I've got an entire JSON string, which I just plop it, and it gets stored. The other thing which NoSQL database has got is the identity column generator. So I have not created an ID column here, but when I've created the table, I've said that my primary key has to be auto-generated, and that actually creates the column as the rows are getting generated. Right. Next, we look at the subscriber. So like I had mentioned, this is the reactive streams API. It has been implemented using the reactive streams and typical publisher subscriber model. So you publish on the KV store and you subscribe on one or n tables. And so this is my table which I want to subscribe on, and this is where the data lake is where I'm going to push all my data into. So it will keep listening to the CAP customer profile table, and as and when I can write filters in my subscriber to say if there are delete operations, do this, if there are update operations, do this. So I'm listening on just the put operations, which are inserts, and then I would push that data into any put operation which comes in gets pushed into the data lake. So there are a bunch of configurations which come in, how many subscribers I can have. There are no limit on the number of tables, but you can define the number of subscriptions that you would like to create rather than just dump in every table with a subscriber and then slow down your database. The NoSQL database streams also has got a checkpoint table which allows you to, so let's say you're streaming your data from one table into another, and in between there's a network outage and your streams stop. What do? Where does it start from again? So that's where the checkpoint table comes into picture, where it knows what is the last transaction when the network has broken, has been disconnected, and that gets checkpointed. And then when this subscriber starts again, it actually reads from the checkpoint table the last, we call it as a VLSN, so last row which has been read, and it starts streaming from then. So I create a NoSQL publisher config, and I will show you. So this is the NoSQL stream subscriber, where I have created a subscription and the number of transactions which I would like to subscribe to. So let's look at the stream subscriber. Sorry. No, it doesn't. Yes. So it has implemented the reactive streams like I just mentioned. So there is a publisher and there are subscribers. And there is a, so internally it uses the NoSQL, what do you call that? Chain stream, yeah. Chain stream is there, but the master and the replica nodes. And there is, as soon as the an event has occurred on a particular row, like a put event, then the data gets streamed from a tunnel into a subscriber. So the subscriber is something that which you will be implementing, and then you decide on where you want the data to go, or the subscription which you have read. So I'll show you. Yeah, it's node-to-node communication, yes. Sorry? So you can see here, this is the so this is a typical filter that I have written, where so whenever an event has occurred, it goes into the onNext method, and then in the onNext method, I would identify the kind of operation which I am listening to. So it could either be a put, or a delete, or an update. And for this put operation, I would like to pull the data which has been streamed into, convert it into a JSON row again, and then push it into my data lake. Right, so that's what I'm doing here. So let's look at the Spring Boot. So the microservice is typical Spring Boot project, where I have a controller, I have a model, which is where which would be either booking a movie ticket or a metro ticket. And then the controller has got one REST service, which is booking a movie ticket, booking a metro ticket. And I generate a date time for it, and then just push it into the metro booking table. So what I've done here is, instead of in my data lake table, I would end up having the customer profile and the transaction, the CAP transactions that he does, and all the value-added services like these microservices of either booking a metro ticket or a movie ticket. I have made them as child tables to the parent data lake table, for the simple reason that I don't want my JSON to become unmanageable at some point in time. Today I've got just 2 services, but then as and when I have more services, the JSON will just keep on increasing. NoSQL database also supports in-place updates for JSON documents, which means I can go to a particular attribute and just update that particular attribute inside that JSON, or add more to that JSON. But then I didn't want to use that for the simple reason that, like I said, it's just going to become unmanageable. Looking for a particular attribute inside that JSON is going to become a hell at some point in time. So I broke them into child tables, and what that allowed me is to be able to query data from that child table using the parent table's ID. And similarly, I can also run my analytics on top of just the child table, rather than looking into the parent table, drill down into my JSON, pull out just the movie ticket, movie booking information, and then show it on the UI. So that would have been a costly operation. So this was much more easier approach, because NoSQL database supports child tables. It is done at the NoSQL level. In terms of whenever I'm inserting into the child table, the ID column from the primary table automatically gets pushed into, the reference is done, but then when I'm pushing into the child table, I'll have to push the primary key ID. So in case over here, so if you see, ID is the primary key ID of the primary table, whereas this is the entire JSON for that particular service. right? So that's the, if I don't give the ID column, when I'm inserting into the child table, NoSQL will complain. It will say you need to refer your primary key row before you push into your child table, but then it doesn't automatically insert the child because it doesn't know, right? To which primary key table row you want to refer, that you as a developer will know. So yeah, I am storing in both the places as JSON, but then it's up to me as to how I define. So like I said, it's every microservice which I am going to build, I'll have it in an individual child table. For the simple reason that I may book one movie ticket today, but then over a period of time, in a year, I would have booked 100 movie tickets, which means the number of movie ticket records are just going to grow. And instead of me storing it in the primary table along with the cap transactions, which by itself are too many, my JSON just becomes unmanageable. That was the reason I chose the child table operation. Yeah. So the primary table will have its data, the child table will have its own data. We are just creating a reference between the primary and the child table. Great. And finally, the render charts. So this is a, so I wanted to use the Oracle's data visualizer tool, but then I found it too heavy to use. I ended up using Fusion Charts, if anybody has used that. So that's a JavaScript, lightweight JavaScript charting tool. It gives pretty neat tools. You can drill down and do a lot of things with that. Pretty easy to get started as well. You download the JavaScript API, plop it into your project, put the JavaScript in your class path, and then you're good to start. So I've used that. More than the JavaScript tool, I would like to show you the queries that I'm running. So these are the 4 charts which I'm showing. I'm sorry, they don't. Anyway. So this is how simple it is to run a query in NoSQL. So I'm saying select count, all the counts of movies that customer with ID 1 has booked in the last 1 year. There are NoSQL queries allow you to extract months, days, and years from the date. It also allows you to give path expressions to reach into your JSON attribute. So for example, if you see here, movie booking details is the parent JSON attribute, and in that there is a attribute called as create time. So you can go into at any level. So it's a nested, you're allowed to nest into at any attribute level. It also allows you to create indexes on nested attributes and complex data types as well. So you can create indexes on your arrays, you can create indexes on your maps. At the same time, scalar types like integers and strings, stuff like that. So a similar query on the number of metro booking tickets that customer has done. And then there is the total number of cabs that a particular customer has booked over the last 1 year. So it's as simple as, so I'm storing them as an array of cab bookings for a particular customer, and I can find out the size of the array. So these are inbuilt functions in the SQL query for NoSQL. There are aggregate queries also in NoSQL database, like sum, average, which can be used. So in this case, there's another 4th query where I'm finding out the total amount that a customer has spent on booking movie tickets. So these are kind of analytics which will help me to understand my customer a little more, to say that how much of money does this guy spend on booking movie tickets over the entire year. Right? So is he somebody who is a movie buff or somebody who enjoys using public transport? these are kind of analytics which you can extract for a particular customer. Great. So let me quickly run this program. So I've got some pre-built JSON data which I had. So these are the tables which I've created. Sorry, I should have shown this before. This is how I identify my primary key. Then this is my data lake table. This is how I define my JSON column. Then there is the child table. This is how you define your child table in NoSQL database. And similarly, your child table for movie booking. Right. So if you see here, I have not identified the primary key for the parent, because I have used the notion of data lake dot metro booking, which means data lake is the primary key, whereas metro booking is the child table, is the primary table, and metro booking is the child table. And the primary key of the data lake table is going to be referenced in the child table for every row. So I just loaded a bunch of CAP transactions. You can see here I've started my publisher, and it has subscribed to all the rows from the primary table, which is the customer profile, into the data lake. So this is the SQL shell for database, which will allow me to query into individual tables. So there are about 242 customer information. Similarly, I will. So these are all the data which have been streamed from the customer profile into the data lake table. Right. 242 rows. I have my microservice running already. So this is the customer booking and the metro booking. So let's book a metro ticket, a simple REST API call. Okay, I'm sorry. Yeah. Okay. So you can see that there are 175 rows for a particular movie booking that has been done. And if you see the structure, there is the primary key table row, and these are the movie booking details for that particular customer. So similarly, you will have multiple rows for primary key, for customer ID, for customer with ID of 8. Right? So instead of we having one big JSON, they are all individual rows in the table, which you will be able to query faster. So this is the kind of charts which I have been able to pull out from my database. So it says the total number of bookings for the entire of 2018 that customer Tara has done. It says that in January, she's ended up booking 14 times movie tickets. So either she was celebrating a birthday or there was something else which was happening. Similarly, metro bookings have shot up only in January, whereas the rest of the year, she's been using it more or less in a similar fashion, but just in January you can see those two spikes. So either there is something which I have understood about Tara as a service provider to say there is something which is happening in January that she will end up spending again in 2019 or in 2020. So number of cabs. So these are more of real-time indicators, which will show the total number of cabs that she has booked in the last 1 year is about 75, which means she does book at least 5 to 6 cabs in a month. So she's a prolific user. Similarly, the total amount of money that she has booked on booking metro tickets is more than 5,000 or 5,500. That means she's a real believer of using public transport than her own. So, these are kind of information that you can gather if you have these kind of value-added services clubbed along with booking cabs. So that way I've got complete information about Tara, which I'm trying to maintain in my database. And this is not just about booking movie and metro tickets. There can be multiple services which can be added. Like, I can try and, if I'm going for a marriage and I've booked a cab to a marriage hall, and there is some way that from my social profile, I understand that I'm attending a friend's marriage. So why not prompt him to, do you want a flower bouquet to be delivered before you reach the marriage hall? That's the kind of services, and that's the kind of understanding for the customer that you can build. So yeah, this was pretty much what I wanted to show. Open for questions. Try to keep it less before 5. Managed to do it. Sorry.
As the number of movie bookings was high for Tara in January.
Yeah.
So, for example, suppose taxi company cab service has that data. So they cannot achieve that. That for the month of January, I have to make sure that I'll have kind of more bookings from Tara during. But when you say the booking count was high for January, it doesn't mean that she will be booking.
Yeah, so it's not that I can 100% say, but there is some amount of information for me as a service provider to say, why did she go about and doing it only in January and not in the rest of the year? So there is some thinking that I can do, right? So at this point, it was just about booking movie tickets and metro tickets, but there could be a lot of other things as well, by which I can build my social profile. Yeah, so this was just one example to show, but then there could be a lot more information gathered about Tara to say that why did she do that. Yeah. Any other questions? So this is where you can find NoSQL database. We also have a cloud service, fully managed cloud service, which can be used free for 1 month. You can, and at the same time, there's also a downloadable version, a local downloadable version of the cloud database, which you can download, start playing around with. Very simple to use APIs, and they are compatible. So you build your application on the on your local database, and when you're ready, point it to your cloud service, and they work seamless. There are also a lot of tools like Eclipse integration, Eclipse tools, IDE integrations. We are also integrating with the Oracle's Visual Builder Cloud Service, which is IDE on the cloud, to give you a more seamless development experience using NoSQL database. Yeah, that's what it is. Thank you. One second. Yeah, sure. I'll put it on GitHub. It's not.
All right. So today I'm speaking about concurrency and parallel programming in Java. How many people work in Java? So many people. Wow. Now I'm nervous. All right. So I'll start off. Okay, thanks. So this is, I'll just talk about these things in brief, and then I'll show a demo. So I don't have any Eclipse or any IDE on my system. On this is a new system, so I'll just show you the code. I can just explain it, and I'm sure everybody will understand. All right. So what is concurrency? And everybody knows. So maybe people, I'll ask the audience itself. Anybody? Concurrency. So everybody is. This is the last talk. I know it's everybody's waiting to go. I thought it'll be more interactive. Fine. So concurrency is basically, according to the dictionary, what does it say? English dictionary. It says that it's two or more events that are happening at the same time. So that's what is defined by concurrency. So in terms of computer science, what does concurrency mean? So concurrency is execution of tasks at an overlapping time period. So that means is, like for example, if there's a person who's vending tickets, and you have two queues, like two lines of people waiting for their tickets. So then he can parallelly give give tickets to both the lines. As he's going on like printing it, he can take the details of the next person. So as the printing is happening, so this is what concurrency means. It's basically that you're multitasking, basically. Well, in parallelism, it's more like where it's it's not like the pseudo parallelism that's in concurrency. It's more like separate processors are there, and you have each processor that picks up one task and simultaneously executes those tasks. So according to the dictionary, parallelism or parallel is occurring at the same time or side by side. So here we have two vending machines, and both of them are picking up the tasks side by side. So at the same time. So then, how does the CPU support concurrency? So we know that in the CPU there are like a single core or a multi-core application, and in a single core application, that's where parallelism is achieved through multitasking, or where each thread will pick up one particular task and it will overlap over the same time period. So in case of multi-threaded applications, the CPU it shares with the threads share the same the translation buffer, CPU's caches, and the computing units. So all this is shared between the threads. Okay, just hang on, guys. That's it only. There are two there. I can remove it.
Can you put that PowerPoint back?
Yeah. All right. So like I said, multi-threading is where the CPU will the threads share certain resources like the cache and the translation buffer. That's where it the translation buffer where it stores the memory for between the actual file system. It has a cache where it can store this before it actually hits the file system. So there is also something called multi-processing. Multi-processing differs from multi-threading, where it's basically you have multiple cores, and each core will have one application running on it. So now the advent of multiple cores, CPUs, this is how it does it. So multi-processing and multi-threading are both can coexist, and they both complement each other. So then, how does it actually work at the CPU? So the CPU has it executes any task or application in something called clock cycles, and it has an internal clock that and at each tick it will that's how it identifies a compute cycle. And so when you say like to 2000 gigahertz that you listen to, what does it mean, like 2000 gigahertz? 2000 gigahertz is actually 2 billion cycles that is executed per second. So that's the speed. And so at that speed, it can pick up and execute those tasks. So, and also when any task is picked up, it can be preempted. Like if it needs to wait for a resource, it can wait on it, and then the other thread can be preempted, and it can start execution. So this is how multi-threading happens. One thread is executing, then the other thread, if it's waiting on some resource. So then now I'll talk about on Java language specification in SE8. What are the different constructs that are available? Constructs that have been added. So So we have about trying to make it synchronized, or why do we have those keywords? So it should just be available for us. Why doesn't Java actually give it to us directly? Because when the JVM, it picks up your each of the lines of code, and then the compiler, each thread code will be in parallel, but it can those lines of shared resources being not executing as per how you want the code to work. The programmer has to take care of it using the constructs available. So that's why you have some higher level constructs and data structures that provide concurrency. So these locks are implemented using monitors. And so at any point in time, only one thread times. If it has a lock, it can again acquire the same lock multiple times. And if it and then the same lock, when it does the unlock, it just reverses. The synchronize keyword, it internally uses locks. And if you attempt to use any synchronized keyword, what on this this is your current instance on which it will acquire, or if it's a class. And once the execution is completed, then also it can, if it's interrupted, if there's any interrupt that happens, then exception and continue your execution. So which are waiting on that particular lock or on that object. So these waits. So when you call wait, what happens? It'll when you call wait read from that wait set, and it will, if it's currently in wait state, with that caller method, if it calls the interrupt, then it will throw the illegal block, or only then you can have the wait executed, the wait method executed, else it will throw a illegal monitor state exception. Notify, it will select a particular thread from the wait. It will release the lock, the current thread, and then it will the thread that has been so however, if you call notify without when it's not in a wait, when it's not inside a synchronized block, if you call notify, then it will throw again a illegal monitor state exception similar to wait. Rough time a lock has been called, has been set from different threads. So each object maintains this variable. So and one of the threads can pick up the lock and start execution. So interruptions is when thread.interrupt, you click the thread on which it is called, it will cause that to resume execution, but it will throw the exception, interrupted exception. I'm sure everybody knows. Anybody? Yeah. When it's actually when one thread is reading, is reading, and the other thread is writing. So in this case, it's the write happens after the read. So in this case, it's not reading the updated value, right? Because you want the updated value to have the latest. So for example, I have this table. It has like thread 1 and thread 2, and those equal to A. So all of these are variables, R1, R2, A and B, and A and B set to 0. So let's see what happens if setting the value to B. So and then in the next line, B is set to 1 and A is set to 2. So here in this case, A is not updated. In the second line is where the value is being updated. So it will show R2 equal to 1 and R1 equal to 1. That's because the compiler can rearrange the code like this. 2 is made line 1. So in this case, it updates the value for B, and R1 reads the value of B. So it reads 1. So this is what happens with the data race. So when there is a write in one thread and a read of the same variable in the other. Blocking queue demo. I just have the code. I don't have I can't execute it. So I'll just a member variable. And so I'm setting the capacity in the constructor here. I'll increase the size. I don't know if you can see it. I'm not able to increase the size. So is a capacity. And what does blocking queue do? You have a producer and a consumer, and the consumer waits till there are values for it to consume, and the producer till it has any elements to read. So in this case, so the put is the method that I'm using to add if the size of the queue is equal to the capacity. So if it's equal to capacity, it should block, right? Because that particular queue, that particular thread that executing it will have to wait. Then if it's not, equal to the capacity, I just I add the element into the queue. And similarly, I have the tick. In this case also, it will a similar while loop I have, and I wait on it till it's I have a main method. I'm just adding 5 elements and then reading it, and I start I'm creating 2 threads, a producer and consumer, and then I do start. So can't run it and show, but what can be a problem with this? Like it's properly functioning, but what can be a possible scenario, like if you have the bigger picture with more threads in it? Well, yeah. Because of the wait, because of the while loop. Okay, yeah, that's one thing. Other than that?
Like when you got multiple threads, you does not know which sequence it will get executed. Which state will be executed first or later.
Correct, yeah, that's one of the main issues actually. So the thing is when you have like I said, there's a wait set, and all these threads will be added to the wait set of this class, which is the blocking queue. And so when I'm doing notify, right, I call notify both in the producer and the consumer. When I'm doing get and put, I'm doing the notify, right? So notify will cause one other thread to start execution. Ideally, if a producer is adding, if the queue is empty and a producer is adding an element, the first element, then the consumer can pick up the element. So it should unblock the consumer. But if there are 2 producers and and one consumer, and you have this one producer that says, okay, it notifies, saying that, okay, the consumer can pick up. But however, there's another producer as well in the wait set. So that can also pick up the, that can start execution. So what happens is that when it starts execution, again, it will see that, it doesn't do anything, obviously, because it either adds an element or it does not remove it. but still we want the consumer to be picked up, not the producer to execute. So this is a problem here, where you cannot ensure that that particular thread. In this case, we want it like producer consumer is like a pipeline, right? You have a pipeline of elements being added into the blocking queue and elements being read. But in this case, there's no way to determine which is the order. Will the producer always be picked up, or will it be producer consumer, then again producer consumer? Will it be like that? So other thing with this code is that if it can lead to starvation. Starvation is where when one thread is if there are like hundreds of threads in your wait set, so few of the threads may not be picked up because it's picked up at random. You never know when that particular thread will be assigned. There's no sort of ordering or a queue of when the thread is picked up. So the probability of the starvation is, in this case, I mean, in small applications, you don't get starvation, because this is normal. Like I tried to with multiple queues and multiple threads, it never faced this problem. So you'll ideally face this problem on, like when you have 100 or more threads that are executing. So that ideally you will not even have on normal systems. It will be only with like Xeon or other CPUs that you have, where on big data that you run so many threads. You never run so many threads at once. So even running threads, also multiple threads, is detrimental, because even managing threads also will actually eat up into your resources than actually helping you, helping the execution, like reducing the time of execution. So management also is you need to take care of. You cannot have too many threads. Depending on the number of cores, ideally you'll have that many threads. So, so the one way to avoid this is you can use reentrant locks. So this reentrant lock will ensure that there is no starvation. It has a fairness principle Yeah, priorities also you can use. You can set the priority, and I've not tried that, but that you'll need to take care of, like setting the priority for each queue and I mean for each thread. But if you don't want to go to that detail and allow your application itself, your JVM, to take care of which thread is next in queue, like it'll based on the which is executed, which is first does a wait. So it'll call that particular in orderly fashion. So I don't know what is happening here. Fine, I'll just I'll put the code, everything on GitHub, and you can see. How do I put this on? Okay, yeah, just make it duplicate. Don't want of. Okay, 1 second.
1 second. You need duplicate.
No, not. Yeah. So. So here I use the reentrant lock, and then so I have two conditions, not full and not empty. All right. So what this does is I have two conditions on which I can wait. So I'll for the producer I'll wait on something called not full, and on the consumer I'll wait on not not empty, right? So, for example, when I do a put, in this case, I first call lock. So this is what the synchronized also, it's the same thing. So the lock and unlock where I'm doing here is will be the final synchronized block for me. So within this, the entire code is synchronized here. And I do wait on not full. So that means when it's not full, it's like so when I'm doing a put, I'll see that I signal for the not. So the take or the get will signal not full, saying that it's not full. So anybody, any thread that's waiting on the not full can pick it up. Similarly, the producer will signal not empty to say that to say to a particular consumer saying it's not empty and you can pick up, right? So. So the producer will tell the not full queue saying that so who's listening on the not full? The consumer is listening on the not full, and it will signal that saying that it's not full. You can pick it up. So that's why I am signaling here in the put to the not empty here, and similarly in the take I'm signaling to the not full, saying that I'm not full. You can one of them can go pick up. One of the producers can pick up. So here I'm just saying producer can resume execution in the take, and here I'm saying consumer can resume execution. So I'm actually specifying who should execute next. So in this way you can also specify the ordering of your threads, which should be executed next. And also apart from that, like I said, the reentrant lock has its own fairness principle, and it will ensure that any of the queues, any of the threads waiting on that in the wait set for it will be next resumed as it was added to the particular wait set in that order. Okay, next I'll move to fork join. So fork join it was designed such that with a divide and conquer principle, and so it speeds up the execution by dividing tasks into smaller chunks and executing them in parallel, and then obtaining the results and combining them again. And this is a recursive procedure, and the subtasks should be independent of each other, and they should also be stateless. So that there is no any data race. Obviously you don't want that, and because it will call recursively, you don't know how the state of the variable will change. So there are two parts, fork and join. So in fork, it's dividing the task into smaller subtasks, and join is where you combine the results, and you wait for the result obviously, and then you combine it. That is where the join happens, similar to map reduce. How does it work, the fork join? So it has it uses a thread pool, and if you can create you can use your own factory, which you can specify when you create your thread pool. When you create a constructor, you can pass in your own factory for it, or you can use the available factory, which I will show, which is a common pool factory that creates the number of threads equal to the number of cores. And so each thread, in this case, will be given a double-ended queue, and in this case, it can be double-ended queues. It can be added and removed from both the ends, and so here, if a thread, as there are multiple tasks, and these tasks are divided between these threads, and these tasks are added to the DQ of each of these threads, and when a particular thread has no task, then it can go and it can steal from another thread's DQ. So that's a work stealing algorithm that has been implemented. into fork join framework. And so fork join framework has two main classes, fork join pool and fork join task. Fork join pool is the implementation of your executor service interface. And it has, the only difference is it has the work stealing algorithm that is implemented, the differentiation between executor service. So there's, so now how do we create a fork join pool? So like I said, you can use a common pool. That's a static method that you can use, and it will create number of threads equal to the number of cores that are available. And also another advantage is that it recommissions those threads if it completes its execution, and then the threads are added back to the pool, and then it can be reused for other purposes whenever like common pool is again used. So it can be reclaimed. So that reduces the resource usage. And fork join task is used to execute your tasks. So similar to you have runnable and callable. So you can use these two recursive action and recursive task, which is the subclasses. So you have to extend one of these two classes for running your fork join method, like creating a task. So when you create a recursive action, you don't get a return type similar to the runnable, and with the recursive task you get a return value similar to callable. And so with fork join task, you have two methods, fork and join. So fork allows fork join task to be scheduled for asynchronous execution. So it creates a thread, or it actually picks up from the common pool, and the task is assigned when you call fork. So a new subtask is created from the existing one. So when from that particular thread, it will assign this task to the parallel thread that it invokes, and you get it from the common pool. And join is where you wait for the execution to complete. So this, how do you split it, your task? So if the problem is small, you split. If you follow this algorithm, you directly solve the problem if it's too small, because it doesn't make sense to split it into further subtasks if it's too small, like the end condition. And else you split it into independent parts. You then fork each of those new subtasks to solve each of the parts, and join all subtasks and compose the result from the subtask, and then you can return the result as well if need be. So this is basically all fork join. All of the problems will use this algorithm. So here you can use multiple methods. You can use execute, or you can use join, or you can use invoke. So with execute, you just call you create a recursive action. That is any task that you extend from the recursive action class, and then you call the join, or you can also do a submit. The only difference between submit and execute is that it returns the recursive action as well. So then you can do a join, pipe it and do a join, or you can do invoke. There you can actually get a return type. So that is what is typically used. Yeah, I'll go to the code and I'll show you. So I've created this code where I'm having a list, and this list I'm adding the elements of the list. So this can be ideal problem for divide and conquer, right? Because they are stateless. Each sub problem I can add separately, and then then the result of that I can add to the result of the next, and I don't need to worry about any ordering or any data race problem. So in this case, I've created so I have a threshold of 5. So here I'm just setting it for now as 5 is at which it should execute sequentially. Above 5 I will execute it parallelly. So I have this, so this is the task. The sum action is my task here, and so for each of them you have to override the compute method for this for this task, the sum action. And and also you need to store your data in a member variable, because you cannot pass any arguments to your compute method. So I'm storing the data in my constructor. And so then so in compute I'm checking, first is the, similar to that algorithm, first is I'm checking if there's a, if the basic condition, if it's an exit condition. For me here it is whether it's less than the threshold. It's less than 5 elements, I add it sequentially, the 5 elements. But if it's greater than 5 elements, then I will divide it by 2, and then each of this, so this subtask I create 2 subtasks. One is from 0 to mid, and then another subtask is from mid to the end of the list. So then I do a fork which will add this task and give it to a to the thread from the common pool, and then I call compute. So this compute will just execute it in this current thread itself. So one I'm giving it for the for a thread, parallel thread. Another I'm executing in this thread itself. So the compute will execute, and I'm waiting for the join. I'm waiting for the result of the first thread. And so once I'm obtaining the result. So with this is how I can do the compute. And here you can see that I'm in the compute directly. This is just a sequential execution. I'm just, for those 5 elements, I'm iterating and just adding it and returning the value in that case. So this is my main thread, and here I'm just creating a list, and I'm calling this action. I'm creating a new task of some action, and I'm passing it to the invoke. So here I'm using the pool as well here. So fork join pool, and I'm passing this task some action to the invoke. So in this, here I'm using a recursive action. So I'll show you how you can use a recursive task. So recursive task is where you can return a value. So in this case, it's similar. It's similar to the previous one, except that I can return the value here. So here I'm getting the return value here. In this case, I'm not getting a return value, and I'm executing this value and then obtaining the result here. So this invoke will actually return me the result of this, similar to the previous one. So I ran this particular method. I mean, this particular example for around 1 million, I gave it a 10 million list, and I ran multiple iterations, around 10 iterations for different thresholds. So first threshold for me here, the threshold is my sequential limit. So 1,000 I set for the for the first time, and then I increased. I made it 100,000 and then 1 million. So this is the threshold at which it is the exit condition, and it executes sequentially. So I get the values of 52.9 milliseconds. And when I did it 100,000, I got 28.4 milliseconds. And when I did for 1 million, I got 31.8 milliseconds. So as I'm increasing the size, you see it's increasing here. But surprisingly, you see that I'm getting in sequential, just normal code without using fork join, I'm getting 18 milliseconds. So why is that? After using the fork join, still I'm the execution seems faster in sequential. Why do you think? Sorry? Context? Context switching, yeah. That is one of the reasons. And also it's a pretty simple task, your addition, right? It doesn't take so much time for the execution to occur. So there's no point in splitting it, because it's like the person said, it's context switching, and also it takes more time for management of your threads rather than actual execution of your program. So that's why, so it depends. So when you have a more complex task, you can use it. But even in this case, you need to do multiple runs to see which is your ideal threshold. See, for 1,000, I've got 52 milliseconds. Then for 100,000, I got 24. For 1 million, I got 31. So you'll need to do multiple runs to see which is your ideal threshold that you want to set, because it's a balance between your the thread management and so if you create multiple subtasks, I mean the subtasks for your particular task, it can actually be detrimental rather than executing everything at once. It has to be a big enough chunk. In this case, the sum is not a big enough chunk to execute in parallel. It executes too fast. So you have to ensure that the chunk is big enough. That's why your threshold should be more when you execute it. I think that's it. I'm done for the any other questions? Yeah, translation list buffer. So that is more like when you have an intermediate cache. Okay, so that is part of your CPU, and that is used by multiple threads. Can reuse that particular cache, and that is used for when you need to do any reads which needs to go to your memory or even a RAM or even your particular ideally it's even for your RAM, like in memory as well. You have this TLB in between that will execute it faster, so that when you have multiple threads running, it can actually reuse that, because some of those data can be shared, and it's ideally like a cache, right? You reuse existing data because you feel that the algorithm feels that it can be reused, the data. So that's why you have this TLB where you can reuse it.
In one of the sessions today, they are talking about spinning and pinning. What is the difference between these two? Spinning and pinning?
Okay, what is the context?
In context to this thread only, one of the sessions in the school, they are giving the demo for the Java.
Okay.
The spinning command is, they say that like when you wait for the thread, that is a spinning. But pinning, some word here use pinning also.
Okay. I'm not certain.
It was related with that Java only, like
okay.
In the school they are saying like how you can reduce that time.
Okay.
Like executor framework is there, then why we are still doing with the...
No, this is the executor framework will not give you this divide and conquer that you have, right? So that is not available in this.
Will you create the thread using that, like
you can do that. See, another thing is you have that work stealing algorithm that's not there in executor service or executor framework. Yeah. You should try it out once and try it out and see. Yeah.
So when you look at the bytecode, it is translated to monitor enter and monitor exit. Whereas when you use explicit log, so I don't see any corresponding bytecode. It's basically some other kind of memory model they are using.
Okay.
So can you explain how that is happening actually?
Okay. Which log did you use? Reentrant.
Yeah, both doesn't have. Whereas intrinsic log is directly translated to instruction.
Okay. I'll take that offline. I'll explain that. All right. Thank you.